folks and some intro slides. So thank you everyone for tuning in with us today. Next slide, please. Good morning. My name is Itzel Torres with 3C Ren. I have started the recording, so you'll all be getting this recording later on this week in an email with the slides. Today we have practical ways to address embodied carbon with Michelle and Tatiana from Imbalanced Green Consulting. So before I hand it over to them to get us started, just a couple housekeeping slides for folks who are new to our program or just new to our network. We ask that everyone make sure they are on mute throughout the duration of the course. If you would like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself. And we also encourage you to participate and ask questions through the chat box as well. We'll get to that later on in the session, or if Michelle and Tatiana can answer through the session, we'll go ahead and do that. A little bit more about the Tri-County Regional Energy Network. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Ren is funded by ratepayer dollars, which are collected through the Public Good Charge Fund and our utility bills. 3C Ren currently offers 3 programs. The first one being our Energy Code Connect program, which serves building professionals by offering Title 24 support for everyone from plans examiners and inspectors to architects and contractors. Within the Energy Code Connect program, we offer our Energy Code Coach service and over the phone, online, and in the field support for Title 24 related questions for both residential and non-residential projects. And we also offer trainings and support. Next slide, please. We have our building performance training program, which serves building professionals such as architects, engineers, contractors, and real estate professionals by offering technical and soft skill trainings related to building science principles, high performance building, marketing, and communication techniques. Next slide, please. We have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll hand it to Michelle and Tatiana to get us started today. Thank you so much.
Thanks so much, Itzel. My name is Michelle Zimney, and I'm a senior sustainability consultant with Imbalanced Green Consulting. And Tatiana and I are pleased to be presenting today's webinar on practical ways to address embodied carbon. Let's see, I'm driving at the same time I'm talking. Let's see. In this presentation, these are some of the items that we'll cover. Most of you are probably familiar with the term embodied carbon, but we'll go over the difference between that and operating carbon, as well as some other relevant terms for today's presentation. We'll talk a little bit about why we need to care about embodied carbon and why now. Look at where embodied carbon is in the construction process and how it's sort of categorized and measured. We'll cut right to the chase and look at some practical steps and shortcuts for reducing embodied carbon in your next projects. We'll take a particular look at Cal Green's intervening code update on embodied carbon and methods for compliance. And then a little inspiration at the end, looking at storing carbon into the future with new materials on the horizon. With that, I do want to reiterate that we're happy to have questions offered during the presentation. So go ahead and put it in the chat. And if there's something sort of urgent, we'll try and address it immediately. Otherwise, we do have a question and discussion section at the end. So a quick look, just again, as a reminder, the difference between embodied carbon and operational carbon. You can see it's a division over time for the most part, with embodied carbon being incurred mostly up front. And it refers to the greenhouse gas emissions that arise from making all the building materials. So the manufacturing, extraction, transportation, installation, as well as a little bit of end of life. Operational carbon is more focused on the emissions due to energy consumption, and that does include water consumption, or is at least related to it as well. When we talk about carbon, we often use kilograms of carbon dioxide equivalent, and you'll see that a lot on some of the documentation. And that's used as a proxy measurement for embodied carbon. It's also the measure of unit, or the unit of measure for global warming potential. So let's take a quick look at some other terms. Here's global warming potential, and we see that that proxy measure is there. We'll talk about EPDs and HPDs. The difference being EPDs are environmental product declarations. Those are the main documents that we look for to get global warming potential data on products, versus HPDs, which focus more on health impacts, such as toxins and pollutants. You'll hear us refer to LCA and WBLCA. They're related, whereas life cycle analysis is a systematic analysis of the environmental impact of a product or material. A whole building LCA is an assessment using that data on building systems and materials as a whole. And then a couple of units of measurement, because there is math, I'm going to warn you. We all know that there are things called tons, 2,000 pounds, but we'll also come across metric tons, oddly measured in, or denoted in capital MT or small t, slightly larger, it's 1,000 kilograms, slightly larger at 2,200 pounds. Okay, so why care about embodied carbon? This graph might be familiar to some of you who attended our Zero Net Carbon Design series last year. Operational carbon in the light blue and embodied carbon in the green. And we know that up front, the embodied carbon is incurred and part of the footprint of any project the day you walk in a building. And it remains the largest percentage of the carbon for your project well into the first 20 years. Something like 80% of your carbon in the first 20 years of your building is going to be embodied carbon. And so paying attention to and reducing that footprint as you build up to construction is really impactful. Here we can see the impact on the environment. So reducing that carbon in the near term basically has the effect of getting us on a lower curve. If we reduce this amount, we'll get on a 2 degrees Celsius curve. But if we can reduce it even more in the short term, it just sets us up for a warming curve into the rest of the century that's beneficial for us. Another curve to take a look at is, how are we going to do it, right? What are the steps toward getting reduced embodied carbon measured, carried out, and then where are we going with it? Right now, we've been working on sort of hitting the low-hanging fruit, gathering data, figuring out standardized forms, building calculation standards. Where we're moving to, and what you'll see in California, is moving toward mandatory reporting and mandatory limits on embodied carbon. We'll talk a little bit about the Cal Green, or a lot about the Cal Green today. And ultimately, where we want to go is keep pushing those limits and moving toward more use of more and more carbon storing materials, so that we can get the low-hanging fruit everywhere possible simultaneously right now as we accelerate up the curve, and ultimately turning our buildings into climate solutions with carbon storing materials. I'm going to hand this lovely slide over to Tatiana to explain why I care about it in terms of Cal Green.
Thanks, Michelle. So why care about embodied carbon? Well, starting on July 1st of this year, you will have to. Addressing embodied carbon will now be part of the Cal Green mandatory measures just for projects 100,000 square feet or more, or schools under jurisdiction of DSA that are at least 50,000 square feet. And then in 2026, the square footage threshold for all projects will decrease to 50,000 square feet. So if the threshold square footage has been met, there are 3 different pathways that you can use. You see those here, and we'll be going into each of these in more depth further on in the presentation. So your first option is reuse for existing buildings or additions and alterations. For additions, this will only apply if the addition is less than 2 times the area of the existing building. And to meet the mandatory requirement, 45% of the structure and enclosure must be reused. The next option is completing a whole building life cycle assessment using approved modeling software. Some of them are free, some also have Revit plugins, and you'll need to show a 10% reduction on primary and secondary structural elements from a baseline building. The third option is a prescriptive path. So, building on the Buy a Clean California program, the code sets global warming potential limits based on industry-wide standards for a few key materials, and all materials listed must come under the threshold. For this mandatory measure, the threshold is set at 175% of the industry-wide EPD global warming potential limits. And as a reminder, Tier 1 and Tier 2 thresholds you see listed below are voluntary, but some jurisdictions may require this level as part of a REACH code or mitigation. Next slide. So now we'll look at where you'll find embodied carbon in the construction process. So you may have seen a graphic like this one before showing life cycle analysis stages and scopes. So construction is broken down into stages A through D, with A being product stage, B the use stage, C is end of life, and D is beyond the building life cycle stage. And each of those stages are broken down further into processes like extraction, manufacturing, transport, and so on. You'll also notice that operational carbon has its own stages B6 and B7 outside of the embodied carbon impact. When looking at data for product selection, you're mostly looking at information covering stages A1 through A5, but if you're doing something like a whole building life cycle assessment, you're going to look further at this cradle to grave scope that covers stages A through C. And now back to Michelle.
Thanks, Tatiana. So once we kind of understand how the construction process is broken down into stages and embodied carbon is assigned to those stages, it's helpful to see where it shows up. And the good news, bad news is, and why we're having this particular webinar, is that it's really loaded up front. So we can see here the vast majority of building product embodied emissions occur in the A1 through A3 stages. So that's extraction, manufacture, and transport. So we have a heavy lift at the front end of building design and construction, but we can also make a huge impact by focusing on those materials and processes, reducing where we can, and getting that embodied footprint lower or even zero or negative with some select use of materials, and setting off the project on a great foot for the next 60, 80, 100 years. Less so, we see, in the range of 5, 10, 15% for each of the following product stages. So the A4, 5, or the B1 through 5, and C1 through 4. Another way to look at it is emissions by materials. So here they actually have a little bit higher number, 93% in the A1 through 3, less so with the Cs. And if we take a look at, well, why is that? Where in the building are we seeing that carbon? We've got floors at about 37%, exterior walls, which are above grade, 25%, interior walls as well, structural, coming in at 15%. And I think if you think about these materials or these sections of your building, what are they made out of? For the large part, they're concrete or steel or other metals. And so this is what we know is that something like 10%, 11% of global carbon emissions are annually, globally, are from steel production or concrete production. Another 8 or 9% is from steel. So 20% or so of global emissions annually is from these two building materials. And so, decisions we make will be super impactful. And then down in more granular look at what kinds of concrete, what kinds of metals. We see that ready mix is used in, for mixes for walls and floors, something like 40% of emissions. So targeting those in particular will make a difference. Rebar, structural steel at 15 and 10%. So either selectively picking those metals and the production of those metals that reduce carbon, or substituting them out for other structure will have a large impact. I'll hand this over to Tatiana.
Thanks. So here we're taking a look at some of the high impact material categories for cost-effective low carbon product selection. As we know from the previous slide, concrete shows highest impact reduction percentage potential at no to low cost premium by substituting cement with alternative cementitious materials. Next, with rebar, we can also see a potential for up to 10% reduction by using rebar with high recycled content. Similarly, structural steel with high recycled content can also make a significant impact. Insulation is another one that can make a big difference by using cellulose or mineral wool batt insulation instead of foam. Glazing is one that can have a bit more of a cost premium, but using low carbon window frame materials and specifying no more than 2 panes of glazing are effective strategies that will reduce embodied carbon. And lastly, finish materials can also contribute by using low carbon and durable materials. And when possible, reusing is best, or designing for deconstruction and future reuse. And now Michelle will take you through some design strategies.
Thanks. So when we talk about this focus on materials and selecting particular mixes or recycled content, we wanted to sort of situate it in a broader framework for design interventions. So up front, I think have all heard the old adage, the greenest building is the one never built. The second greenest one is the one that gets reused. And we see this emphasis on reuse in the upcoming Cal Green Code. Here we want to just emphasize that. Reuse, 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 because all that embodied carbon incurred on the footprint of the initial building is essentially saved with reuse. Right-sizing buildings, obviously, minimizing the space helps us reduce the amount of material used and produced. Once we are building out, reducing the amount of material that goes into an assembly, so dematerializing, simplifying finishes, and optimizing systems so you minimize the excess material. And then here's the focus that we have just been looking at, sort of the carbon storing materials, the product substitutions, looking at EPDs, and substituting out for less impactful products. We don't talk about it much in this webinar, but elsewhere we talk about sourcing. So if you are going to move toward mass timber products or bamboo, you want to look at the way that it's produced and make sure it is in a sustainable way. So with forestry products, FSC certification not only helps produce sustainable wood, but it also looks at the effects of the harvest on soil and carbon emissions after the wood has been taken, similarly with bamboo. And then ultimately, designing for deconstruction and recyclability, reusability is going to bring us back around to number one and help us create a circular economy. So that's sort of the cheat sheet and the quick version of practical steps. We do go into this more in our Zero Net Carbon Design series, and so we'll give you a link to that to be able to refer to in more detail. But now we're going to circle back and look at why we are really going to have to look at this and care about it in terms of Cal Green. I will pause just for a moment because I'm seeing some questions. Tatiana, have you been monitoring those?
Yes, I've been looking at those. Maybe we could address a couple of these really quick. So one of the questions is asking if these requirements apply to multifamily as well as non-residential. So right now it's showing up in the non-residential portion of the Cal Green Code. So if your project is completing the non-residential Cal Green checklist, that's where this will come into play. And then we have another note here, double pane glazing versus triple pane. may reduce embodied carbon, but would have a big impact on operational carbon long term, depending on the climate. So that's a great point. That's one of the things you'll have to kind of take into account as you're making decisions on which products to use.
Yeah, that's an
So,
interesting example of a trade-off where
mhm.
if we are focusing on operational carbon, that triple pane glazing is going to affect overall emissions over the life of the building. But as we were pointing out, the time value of carbon would nudge the decision-making process toward double pane glass because of the embodied carbon incurred with the glazing itself. Unless you've got solar, solar powered glazing factories, and then, you're good to go. Okay, good questions. All right, so like I mentioned, we're going to move into Cal Green and the methods of compliance and documentation for everyone, because that's just on the horizon. Let's see. I think I will, this is the same information we had in a little bit simplified version. And we've got three sort of approaches as a reminder: building reuse, whole building LCA modeling, and a prescriptive approach. Let's start with the reuse. So a slide with a ton of text is always a little daunting, but we did want to get it in front of you because we know that these get sent out and can go into your files, and it's an easy way to just pull up the code without having to go into the full document. And here we're just highlighting the elements that pertain to the reuse code. We mentioned before that you need a 45% document a 45% reuse of the existing building's primary structural elements and its existing building enclosure. Notably, this does not include window assemblies, insulation, or any sort of hazardous materials. There is no incentive to try to keep really bad windows or bad insulation around. Go ahead and replace those. They don't count against you. There is something is important to note, that the existing building, if it's part of an addition, it does need, the addition needs to be less than 2 times the area of the existing building. So, no more than 1/3, 2/3. And we'll have some examples shortly. Okay, so how do you know which method you're going to have? So here, say you've got a 45,000 square foot existing building, and you want to add 50,000 square feet. The first question is it going to even trigger this Cal Green code of a minimum of 100,000 square feet? In this case, no. And so building A is, you don't even have to deal with these compliance methods. Let's say instead there's an 80,000 square foot addition. It is going to exceed the 100,000 square foot threshold. And so then the secondary question is, does it meet that 2 times limit? So is the addition greater than 2 times the existing square footage? Here, it is not. 80 is less than 2 times 45. And so that will qualify you for this reuse documentation that we'll move into next. On the other hand, an addition slightly larger of 100,000 square feet is going to trigger the overall threshold and is more than 2 times the existing square footage. And so then that's going to move you into the whole building LCA or the prescriptive methods. Okay, so then how do we do it? It's a really simple worksheet, right? It's worksheet 3 here at the bottom. And as I move through sort of some of the calcs, I'm just going to be populating it. So with reuse, you're just documenting the existing building square footage and the aggregate additions if applicable. So I've got 80,000 in there, right? And if we just then focus on the existing building, let's say, it's got some dimensions, and as a reminder, we're looking just at primary structural elements and existing building enclosure. So a quick spreadsheet, you make yours as you like, obviously. I've got the primary structure and the existing enclosure elements on the left, and I do some quick math. So, I've got the foundation, the concrete floor. This building, let's say, has CMU walls. It's got some lateral beams and 2 5x5 windows. So I'm calculating the windows, but those will not be included in the subtotal. And I take these subtotals, oddly, they want it by those categories of primary and existing enclosure, and I just drop them into the spreadsheet. And then I'm going to calculate the retain. So I'm keeping the foundation, keeping the floors. Let's say I'm keeping half the walls, demoing the beams, excluding the windows. The roof is framing is going to be gone, and I'm keeping all of the exterior stucco. And what happened? It's not moving forward. There we go. Got those numbers into the retained total area. Calculating out via these sub sort of categories of primary structure, existing enclosure. Why is that? There we go. And renders these sort of subtotal percentages. And then the overall total is in blue of 54.6% reuse. And that's pretty much it. That'll get you, you'll submit that with your plans to show compliance for building reuse. Let's have Tatiana run us through let's see, was there any questions on that? No. So let's hand it over to Tatiana then for a little more complicated approach in the whole building LCA.
Thanks, Michelle. So another little bit of a wordy slide here, but our second method is completing a cradle to grave whole building life cycle assessment with a 10% reduction in global warming potential compared to a baseline building. So this assessment will need to have a reference study period of 60 years. Included in this analysis are enclosure components, including glazing, insulation, and exterior finishes, and primary and secondary structural members, including footings and foundations, structural columns, beams, walls, roofs, and floors. And we want to note that the difference in scope between this method and the building reuse method is that glazing assemblies and insulation are included here. So we get a lot of questions about how to find a baseline, and the code is going to direct you to these ASTM guidelines below, outlining that the baseline building in the comparison must have the same location, orientation, size, function, and space conditioning as the proposed building, and the materials shall be based on typical design construction practices for the project type in the area where the project is located. So in practice, architects we've worked with tend to generate their baseline off of materials they've used in previous projects that are a similar building type to the new one they've designed. So this slide here shows how structural elements, envelope materials, and finished materials typically have higher embodied carbon content. So for the whole building life cycle assessment, the CalGreen scope focuses on the big ticket items, including these structure and building envelope categories, plus the footings and foundations. And while finishes can also have an impact, they won't be required to be included in the assessment at this time, but it is optional to include them as part of your scope. So what will documentation look like for this measure? Whichever LCA software you use, you'll be able to generate a report summarizing the global warming potential reduction, and it'll look something like these examples to the bottom left, showing a graph and a table with global warming potential values. And that will be needed to be included in the construction documents along with this worksheet 4, which will be signed by the design professional of record, confirming that the 10% reduction has been met following the guidelines for the baseline building. And you will also need a copy of the whole building life cycle assessment along with maintenance and training information in the operation and maintenance manual. So here's a few of the tools that CalGreen suggests using for the assessment. There's more out there, but these are the ones that they recommend. So there's Athena and One-Click LCA Planetary, which are free to use. And there are some paid software options, including Sphera, SEMA Pro, and Tally, which has a Revit plugin. So just for an example, this is what a project looks like in Athena. How it works is that projects are modeled using a trunk and branch structure. So users can quickly describe building assemblies through dialog boxes that request simple information like base sizes and loads, and the software does the rest. It'll calculate a bill of materials and the associated environmental impacts for you. users will have the flexibility to add materials as needed, or alternatively, users can import their own bill of materials from any CAD program. We do have a more in-depth presentation, really digging into the weeds on how to use Athena that can be found in part 4 of our CNCD series from last year. And the Athena portion starts at about minute 30. And Michelle's going to drop that link in the chat. So next slide. So after you're done building all your components for your building, that will be included in the scope for this method, you'll want to generate your report. So first you'll select the project for the report. For this one, you'll want to do a baseline case and a proposed case. So you'll be generating 2 reports. We'll keep the report format as a table so we can see all of those values. Define the format by selecting detailed LCA results, select life cycle stage, and click Show Report. Now it's going to look something like this. This is a lot of numbers, but on the left we can see it's broken down between LCA measures, and all we care about for our purposes here today is that first row that says global warming potential. Across the top, we have it organized by life cycle stage, and highlighted boxes here showing data from the product, construction process, use, and end of life categories are the ones we'll need to include in our comparison between baseline and proposed to see if we're meeting that 10% reduction. So you're going to do this again for both baseline and proposed. So 2 reports, and we can compare those values. So in addition to the documentation stated earlier, depending on your jurisdiction, this worksheet 9 might be required by the enforcing entity to demonstrate compliance. So we can see this worksheet includes stages A through C, which we know from earlier covers cradle to grave. And this is where we can put those values from the previous slide that were broken down by life cycle stage for both the baseline and the proposed reports. Right now, depending on the software you use for your analysis, you might not be able to get reports that calculate every single section separately, but they say on here you can leave some squares blank as long as you have the totals that you can use to calculate the percent reduction. So after you have those values, then it's just a quick math problem. So for this example, we can see that this project hit 31% there in the blue. So not only does it meet the 10% mandatory measure, it would also meet the Tier 1 15% threshold and the Tier 2 20% threshold. For this project, the 2 main design moves that were made that made it such a success were a custom concrete mix and the use of mass timber instead of steel framing. And this worksheet also shows other optional materials that can be included in your analysis. But as a reminder, it's just those structure and enclosure elements that are required. And now back over to Michelle to take a look at our last method, the prescriptive pathway.
Thanks, Tatiana. So this is the third method for those who might have a simpler project or don't want to engage a full modeling software approach. It's similar to other prescriptive paths in that there's tables and thresholds that you just have to meet, and it's all or nothing. So the way they're talking about it here is the data that is provided on permanently installed materials listed in table 54093 need to be documented with type 3 environmental product declarations. We'll talk about that shortly. And they need to be of a type that's either product specific or factory specific. And here I've highlighted the name of the title of the table. We'll see it shortly. In addition, the table divides materials into concrete and non-concrete materials, and the method for the concrete documentation uses data from EPDs, it's industry-wide data, but it also involves a weighted calculation that we will go into in detail. So here's the table. You can see the top half lists only 7 types of materials at the moment. It's certain steel, flat glass, and insulation. And those and only those materials, if they're in your project, would need to be documented as coming in under the allowed global warming potential. The units of measurement are a little bit wonky. You just have to kind of track it, and may involve a little bit of math, as we'll see on a later slide. The bottom half of the, and the Buy Clean California material product categories are driving this. They will expand, I imagine, as we move to lower limits and broader scopes, as we have more data. But that's an important note there, because it will help you find EPDs that are compliant. The lower half of the table is the concrete, and you can see here that it's keyed to the strength of the concrete mix that you're using, and each strength, whether it's ready mix or lightweight ready mix, then has an allowed GWP value in that center column. The GWP data for both the top half and the bottom half of the table will be found in EPDs. So for those of you who aren't familiar or haven't had experience finding EPDs, where can you get them? Oh, this didn't go in the right direction. Oh, so here's an example of one, and then we'll take a look at where we get them. So a standard, an EPD is a standardized document with information about the environmental impact of products, including GWP. It's also other measures such as eutrophication. There's a whole sort of a list of data points, but we'll always be focusing on the GWP global warming potential for this purpose. As I mentioned, there are type 3 EPDs, which refer to third-party verified EPDs, not just manufacturer verified internal data. And the scope may be just product specific, it may be factory specific, or it may be an industry average. And attention needs to be paid to that particular scope for reporting on different kinds of materials. So this is a quick look at how you might go about finding an EPD. The EC3 tool is a great database, and it's run by the buildingtransparency.org. You can go to their website, register for a free account, and then just start noodling around. You'll notice on the left side is a column with building material categories. And I'll just walk you through how I found the EPD on our previous slide. I selected construction materials, steel, structural steel, and then hot rolled sections, and I hit next. And it brings up a window where you can enter more specific data requirements or filters. Here, notably, I selected Buy Clean California compliance, and that'll queue to the table that we were looking at previously. I also selected North America, but you might want to be more specific with concrete, for instance, California. The more local, the better in terms of your footprint. And then I hit search. If you are doing concrete, you can enter PSIs and other, here you can enter post-consumer recycled content. So there's a lot more filters that you can work with, but I'm trying to keep it simple. When you hit search, once you have all your filters in place, it will generate a list. This particular product has 33 EPDs in the database. I selected one for Nucor, and that opened up the document. If you page into the information page, you'll be able to verify that it's what you're looking for. Specifically here, it's a hot rolled structural steel section. Notably, the unit is 1 metric ton. You want to make sure the declared unit is uniform. You want to make sure it's valid. Here's a 5-year validity from 2021. It is that product specific EPD type, and the scope is noted as cradle to gate. And then here you'll see where whether it's third party verified or not, and a check mark in the external verification will show you that it's going to work for this particular use. And then if you page further into the EPD, you'll get to the table that gives you the data you need on the global warming potential. There may be multiple tables. In this case, there's at least 2 tables showing GWP 100. The upper one you'll see is metric tons, And then this is a short ton. So you want to make sure you pick the right table with the right declared unit. I've got the top half of the table here on the right-hand side of the slide with the categories. And so here, this particular product, hot roll steel. Okay, is showing 1.22E plus O3 total across the A1, A2, and A3 life cycle stages. And it's in kilograms of CO2 equivalent. Unfortunately, the table calls out a totally different, well, apparently different unit of measurement in metric tons of CO2 equivalent per metric ton. So somehow we need to rectify the kilograms of CO2 with the metric tons of CO2 for our unit of 1 metric ton of steel. So I'll do a little bit of quick math. Basically, the E plus O3 means times 1,000. So we'll take our 1.22 and multiply it by 1,000, resulting in 1,220 kilograms of CO2 equivalent. But notably, a kilogram or a metric ton is equal to 1,000 kilograms. So if we want to get to the units required in our table, the metric tons per metric ton, we're going to go ahead and divide by 1,000, bringing it back into 1.22 metric tons of CO2 equivalent per metric ton. And then we've got it in the units that we can report in our documentation. Oops. There's no particular form in the code, so you might generate your own tracking document, something similar to this table, where you need to list each required material. Again, there are 7 currently, and that's the upper half of the table there on the left. So I've got those under my material column. Here I've you may or may not use each type of material. So I've got Na, for instance, on some. I'm showing the Nucor manufacturer for the hot rolled structural steel. The maximum allowed GWP is 1.77 pulled from the table. And in our product, we have 1.22, and those are metric tons of CO2 equivalent per metric ton. And so we're coming in under that threshold. This product would be compliant, and you would just need to follow that process continually or repeatedly per material and fill out your table for submission. I think a summary table would be helpful, but the actual data that needs to be submitted is going to be those EPDs for the materials used in the project. And that's how you approach the non-concrete materials. Again, limited at the moment, and so pretty doable depending on the scope of your project. If we then move on to concrete, I'm sorry, there's a little bit of delay in what I'm trying to get done here. It's going to be a different approach. So we still use the table, but we need to do a weighted calculation. So let's take that 100,000 square foot addition, for instance, and documenting it. Oh, I'm sorry. I'm going to pause for a moment and see if there are questions that are relevant here. Let's see. What are the custom concrete mixes to reduce EC? I'll get to that in a second, concrete. So where did the 1.77 metric tons come from? That's just the limit set by the state of California, and it's based on 175% of the standard data reported for a product or an industry, depending on the material. A question about, is it known how the code will be adopting products with sequestered carbon like blue plain aggregate? Great question. We're going to talk a little bit about carbon sequestering materials at the end. I do not know at this time how or when or if those sort of futuristic materials or more cutting edge materials are going to be incorporated into the code. It would be fascinating to see where the code starts moving once materials come to market. I see Blue Planet. Okay, got it. Thanks for the questions. And I did have a note to myself to take a breath here because it gets a little bit math intensive. So we're going to shift gears to concrete now. And as I mentioned, there's a weighted calculation. So if we've got our 100,000 square foot addition, this is the equation. Oh, sorry, here's the bottom half of our table, right? With the different strengths and the maximum GWP in the center column. This is our equation that we're going to have to use. And so basically it's the GWP of N, where N is each concrete mix that you're going to use. So if you've got a mix for your perimeter wall, and you've got a different mix for your slab, and you've got another mix for maybe some columns or some beams, each of those mixes will have a GWP that will be used multiplied by a volume to get the overall carbon for that mix used in the project. It'll be compared against the GWP allowed, which is basically the amount of carbon, the GWP value in the table times the volume again. Let's take a look at what that might, so just to block it out a little bit more, the GWP N is the GWP per concrete mix. That is found in EPDs. So that is specific to the mix that you install. And you would probably speak with your local concrete manufacturer to get some of that data, or pull up EPDs and see if you can match the component recipes. The GWP allowed is that found here in the table. So the installed versus the sort of theoretical threshold. So a closer look at the numbers here. There's our equation. And here's a quick table. So in this one, I've got 3 different mixes. We've got a foundation, slab, and columns. They're keyed out at different PSIs. And I've calculated out some volumes. And the unit here is going to be meters cubed. So we're going from square footage in other data points, takeoffs, to meters cubed. So you'll have to do a little math there, right? We're going to pull up the GWP of each of those mixes. And this is going to be found in EPDs that you'll get through an EC3 tool or similar. You're going to multiply it by the volume to get overall carbon, embodied carbon, for the mixes that you're installing. And that's going to be compared against what's allowed. So where do we find what's allowed per mix? We go to the table. So here, the top mix for our foundation at 4,000 PSI is going to be allowed to have 566 kilograms of CO2 per meter cubed. So we're going to take that limit and we're going to multiply it by the volume of 108 meters, or meters cubed, or 1,000 or 12, depending on your mix and your volumes, and get the overall carbon incurred or allowed to be incurred for the volume and the strength of concrete that you have in your project. We'll sum each of those columns to get the sum of your GWP N times your volume and the allowed times your volume. And what you want ultimately is your installed, right, to be less than the overall limit, the threshold of what's allowed. And in this case, we're coming in at less than half. So that's great. In this case, you'd be done. And again, I think this is sort of a table of our creation. You'd have to create your own sort of documenting summary sheet and show your math. But that's going to, I moved ahead a little quickly. So that's going to be the basic documentation for that part of the prescriptive path. Okay, I don't see any more questions coming in, but I'll let that sort of germinate, and we'll just move quickly to our final section of our presentation, where we're looking at some of that, the future materials and how we're going to move toward buildings that are carbon storing structures that move us higher up on that curve, right? So a quick note about carbon sequestering materials. We all know that trees perform that function for us, drawing carbon down as they grow. But there are other materials such as hemp, straw, ag residues, seaweed, cork, mushrooms, bamboo, even algae, right? And why are they important? If we look at the typical sort of carbon incurred for building projects, right? We've got that steep up for the initial manufacture. And then we've got sort of a less steep slope as we incur operating carbon over the life of the building. Here we've got two curves. We've got a typical building, and then we've got one that is going to be using mass timber. And what the use of the mass timber does is that material in sequestering carbon starts our curve a lot lower on the front end. So all other things equal between these two buildings, if you can start on the front end with your incurred carbon below zero, then no matter what else you put in your building and how you're operating it compared to a standard building, you're gonna have less embodied carbon over the life of the project. So that's just conceptually why carbon sequestering materials are important and helpful in this process. We found, Tatiana and I found this pretty inspiring table of materials and categories for carbon storing. The top half refers to mostly biogenic carbon storage, so it's plant materials that are being used for structure and insulation. The lower one are mineralized carbon storage, referring more to sort of hard components like aggregates, concrete, tiles, and bricks. And I'm just going to highlight quickly here the number of materials that are coming down the pipeline that relate to insulation. We'll recall that insulation was kind of a middling category where reductions can be made effectively for low or no cost premium. If we take a quick look at insulation and its impact, foam materials are for insulating are pretty common in our building environment. But we'll note here the net carbon emissions of foam materials is quite high. And even mineral wool comes in sort of middling in those red bar sections. But if we can switch to materials, and this is standardized across R value, if we can start moving our insulation towards net carbon sequestering materials, such as cellulose, hempcrete, straw bale, and I've got some photos here of materials that are coming down the line, cork board, even mycelium board, which is made out of mushrooms, you can see how reducing and even sequestering carbon in a primary enclosure material is going to get us on a lower curve for that building right out of the race, right off the bat, I guess. And so it's fun to see what's coming down the pipeline and keep an eye out for these kinds of plant-based materials. And I'm going to hand it over to Tatiana to talk a little bit about maybe landscapes and expanding the scope of where you think about embodied carbon.
Thanks, Michelle. So when thinking about landscapes, carbon storage can be thought of in a few different ways. Now, this table here has a lot of great information, but before we dig into that, I want to draw your attention to the photos to the right for a few strategies related to material selection. The top image shows an example of low carbon pavers. They come in all different types and colors and are a great option to replace your typical pavers. Another strategy is using alternate materials for concrete walls, which we can see in the image below, where charred wood was used in their place. And of course, a key strategy in reducing hardscapes altogether and minimizing parking lots overall is going to have a big impact. Now, looking back over to the table, this design toolkit from a project on landscape design for carbon sequestration addresses 5 different strategies to incorporate longer-term carbon sequestration into your landscape design. So first, increasing biomass is about adding more plants and trees, especially larger ones if you have space for it. Emphasizing plants with deep roots is going to allow the carbon to be drawn further down into the soil. Increased biodiversity and plant diversity contribute to a more productive and resilient landscape. You'll want to incorporate plants with varying root depths, heights, and spreads. And this is all going to support the soil microbial ecosystem that is key to long-term soil carbon storage. Then designing with plant life history strategies is about choosing appropriate plants for the site. We talk a lot here about emphasizing the use of native and drought-tolerant plants that are going to have an easier time having success in this climate. and avoiding plants that are invasive or will be too aggressive. And there's also emissions associated with maintenance. So plants that require less maintenance are going to help with overall carbon emissions reduction. Lastly, layering and clustering plants, that's going to add to the biodiversity and biomass, creating rich interconnections. And all of these strategies relate back to the soil health, which is critical to sequestration. Healthy soil is going to be much more able to retain nutrients, hold water, filter pollutants, and sequester carbon. So while it's not easy to get a super accurate measurement, there are some tools like iTree or Climate Positive Design's Pathfinder that incorporate estimations of potential sequestration impacts.
Great, thanks, Tatiana. That's it for our presentation, and we're gonna field questions and discussion shortly. If you've got questions, go ahead and keep adding them to the chat. I'm gonna hand it off to Itzel, sorry, for some closing remarks, and then we'll return back.
Thank you so much, Michelle and Tatiana. Really appreciated this training. On closing, we do have AIA units available, so if you have any questions about that, feel free to email me directly. I'll drop my email on the chat. Slides, recording, and a survey are on the way later this week, so be on the lookout for that as well. And here we have some upcoming courses for the month of February. So there'll be the residential load calculation and duct design for building departments. And I'll drop the link to our calendar as well if you all are interested in what we have coming for March, and register for that. And a little bit more about, just a reminder about our Energy Code Coach. We do have a number and a link to our website where you could fill in an inquiry form and get all those Title 24 questions answered by our coaches. And with that, I'll hand it back to Michelle and Tatiana to answer any questions.
Awesome, thanks, Itzel. I'm reminded by looking in the chat that we did give the link to one of our Zero Net Carbon Design webinars, where we demonstrated using the Athena software for building a whole building life cycle assessment. I forgot, as I was presenting the EC3 tool, that at minute 40 in that same webinar, we show in more detail how to go into the EC3 tool and specify what you need to kind of find the EPD that's going to be relevant to a product, or to sort of explore what products are available. So that a more detailed presentation is available on that same webinar at I think it's minute 40. I'm looking at the chat, and I think we actually handled all the questions in turn. Let me see, I'm just going to scale back through here. Oh, I did say I would return to what are the custom concrete mixes that reduce embodied carbon. So in general, mixes that have alternative cementitious materials. So this is the slag and the industrial byproduct waste products that get added and into the concrete in place of cement, because cement, Portland cement in particular, is a very high embodied carbon. Those are mixes that are going to have an overall reduced embodied carbon. Coming down the line, let me see if I can pull up this slide again. Here, whoops, this one. You'll see at the bottom here, there are other approaches in the works where some firms are using algae or microbe grown versions of cement, or creating synthetic limestone. There's a couple of projects in California that are putting out shelves of carbon sucking or sequestering materials, and then that is actually ground up and used as cement in your concrete. So there's no fossil energy used to create that binder in your concrete. And to get the right mix, that's where we refer to, call your local mix manufacturer and see what they can make, what aggregates they can bring, or what cementitious material substitutes they can bring to the mix that's going to suit your use, your strength needs, your curing needs for the particular project and use that you have. And I'm hoping that satisfied your question, Rebecca. Let me know if there was a follow-up. Oh, here she is. Do you also anticipate embodied carbon calcs to eventually come to residential buildings? What would the potential timing be? I haven't seen or heard any specific single family home requirements for that. I think logically, it would tend that way, but I have no specific information about that. And I have no idea on the timing. It's moving pretty quickly, from 100,000 square foot threshold now to half of that in a year and a half, basically. And so I think it's definitely worth looking out for, but not immediately impactful. And then another question from Marco, any foreseen code compliance issues using alternative materials? I think as long as you've got the documentation required, so those EPDs produced by the manufacturer or an industry-wide average, I mean, that's really the currency of the process, where you've got that third-party verified EPD that you can show, hey, this is how much embodied carbon it is, whether it's a mushroom brick or it's steel. I think that is really what you need to be working with, and if you've got it, then you're probably good to go. Any other questions? Oh, Rebecca's back. And I should say that it is 11 o'clock, so if folks want to jump off, feel free. Itzel is going to be sending out the slides, but we're happy to stay for another 5-10 minutes and answer questions. So feel free to keep dropping those in the chat. And we thank everyone for their attendance today. We hope to see you in another webinar soon. Rebecca's follow-up question, in the example that I used for the calculations earlier, the slide said the project was very positive because of the use of custom concrete mixes. And you were curious what that project had actually used. I'd have to go back and look at the specifics. I couldn't tell you off the top of my head. But I know that we worked, it's a project in Santa Barbara, and we worked with Cemex. Basically, they had worked up some documentation for a lead project and were able to take that sort of recipe that suited our structure and strength needs and hand that over to us. And we built a custom mix in Athena, but I don't have the actual recipe off the top of my head. So I really, your concrete mix professional is going to be a great resource for figuring out both what's available and how to meet the specs that you need to meet. Any other questions? Well, that's awesome. Thanks, everyone. I should, Tatiana and I will go ahead and drop our emails in the chat as well. If you have any follow-up questions, feel free to contact us. I'll do mine. Tatiana, do you want to do yours? We're happy to field any questions if they occur to you after the fact. And it's been a pleasure.
Alrighty. Thank you, everyone.
Thanks, everyone.
Happy Tuesday.